Okay, if we can turn to page 15. We're going to do what we did yesterday. It's just now it's going to be with radians, and so feels a little bit more abstract because you're not used to seeing radian values compared to degrees. But everything that we're going to do is going to be very similar. Just instead of 360 and pi or 360 and 180, we're now going to be using 2 pi and pi. Okay. I'm just going to go ahead and skip this portion here because we already know the procedure. We're just going to need that practice. Okay, so you guys can go to page 15, and we're going to go straight to example A. You can have your calculators out. Okay, so page 15. Okay, so first thing you want to do is you want to make sure that you're in radian mode. Okay, so go to your mode button. So that top row here, and make sure RAD, radian, is highlighted. Okay. Okay, so inverse sine of 0.82847. That's the same thing as saying sine of theta is equal to 0.2847. We do the same thing as we always did before, right? We just identify which quadrant that we're going to be targeting our answers for. Which quadrant will positive sign be? 1 and 2. Okay, so let's use our calculator to find our radian value. Okay, I know that we're used to seeing a reference angle that's between 0 and 90 degrees, but now reference angle for radians is going to be between 0 and 1.57, which is pi over 2. So just understand that it feels more abstract because we're not used to seeing this. But same process, though. We're going to take this theta. We know it's a reference angle. And, you know, this may feel like overkill. You don't have to do as much writing as I'm doing here. But I just want to keep, but maybe just do it at the beginning. And then once you're comfortable, then you don't have to do this every time. Okay. Instead of 180 and 360, we're going to be using pi and 2 pi if we're trying to get to second, third, or fourth quadrant. Okay, well, we already have quadrant 1, right? Quadrant 1 is just going to be 0.2887. So we can square that away. Okay. How do you think we can get to the quadrant 2 value? Subtract, yeah. Yesterday, we're doing 180 minus the reference angle. Now we're going to do pi minus the reference angle. Okay, so pi minus 0.288. Seven. 2.853. Oh, sorry, 2. Okay, so hopefully this feels like a familiar process from what we did yesterday. Okay, let's try part B. Okay, cosine is positive. Where's cosine positive? 1 and 4. Okay, calculator. Inverse cosine. Okay, first quadrant is already showing 0.717, and then to get to that fourth quadrant, we can involve 2 pi, right? Two pi minus 0.7169. Okay, part C. Inverse tangent. All right, where's tangent going to be negative? 2 and 4. All your reference angles will be positive, okay? If you see a negative reference angle, then you just, or a negative angle, you can put that in as positive. One side you'll subtract from 2 pi, another side you'll subtract from pi. Hey, how do you guys feel? Okay. Okay, so now the one tricky thing you're gonna experience is inverse cosine that's negative. Okay, inverse cosine that's negative is gonna spit you back, not the reference angle, it's gonna get you the second quadrant value. You're gonna have to find that reference angle and use that to find the third quadrant. So the negative cosine is the only one that's gonna potentially give you trouble. Because everything else, you're gonna get a nice, either a positive or negative version of the reference angle, and you just put that down and you either subtract or add from 2 pi or pi, and all the process feels the same. It's just negative cosine that's going to give you something a little bit strange. Okay, so why don't we skip to those problems now so that we can take care of them, because all these should feel pretty familiar for you. Okay, is everybody okay for A, B, and C? Yes.
So why did you put 1.245 but you can't put C? I understand the 1 point reference angle. How come that doesn't end up in the table?
Right, it doesn't show up because we want a tangent in the second and fourth quadrant because we have a negative tangent.
Okay.
So if the inverse is positive, then yes, you're always going to get that reference angle to show up because we're always using the first quadrant. But if you get a negative tangent or cosine or sine, then the first quadrant may not be used. Okay. But the reference angle is still important, right? We still want to use those to help us find the other quadrants that we're looking for. Okay, so okay, anything else? A, B, and C, you guys okay? So if we can skip to number 6 and number 8, I just want us to get practice with those so that so that we're not thrown off if we were to see it. Okay, so number 6. Okay, where's cosine going to be negative? Quadrant 2 and 3. Now, the strange thing about cosine is that if cosine is negative, principal values is going to spit you out a quadrant 2 value. Okay, it's going to give you a quadrant 2 value. So that's the strange thing here. It's not going to give you a reference angle. Okay, so I know this doesn't look recognizable because we know reference angle is between 0 and 90 degrees, right? But for radians, radians is between 0 and pi over 2. And pi over 2 is 1.57. So anything larger than 1.57 is not going to be a reference angle, right? Now, we don't recognize that because we're not used to seeing something that's in radians. But just to kind of help keep in mind that cosine negative is going to give you something that's outside the region. But the good news is that it's already one of the answers. Okay, but we have to work backwards to figure out what that reference angle is so that we can find that quadrant 3 value. Right? It's like pretend like this. What's giving the angle that's giving back to you is like, 160 degrees, right? And you know that's an angle, and you have to figure out what that reference angle is. Okay. So we'll do pi minus 1.9843. That'll give us the reference angle that we're looking for, and we want a reference angle that's between 0 and 1.57. Okay, 1.1573. So now we can use that reference angle to help us get to the third quadrant value, right? Pi plus 1.1573.
I'm kind of confused. How do we know that that's the answer for Q2?
Because cosine is always going to get you a second quadrant value because it's a reference angle, because it's a principal value.
Okay.
Yeah, principal value. So yesterday, right? Yesterday we experienced this. If I can find my work here. Yesterday with degree measures, we would get back something that's in the second quadrant, right? We know 130 degrees in the second quadrant, so we're able to recognize, oh wait, that's not a reference angle. I got to subtract that from 180. So that's why we did that first yesterday, because degrees are easier for us to think about. But now we have to just recognize that, okay, if there's a negative cosine, put a star next to it, because whatever you get back in return is going to be the second quadrant angle. Okay. Okay, so now we want to find that. So pi plus 1.1573, we get 4.298 or 299. So that's the strange thing about inverse cosine for negative, that the process is going to feel different because the number that you get back in return is not going to be the reference angle. Yeah.
What did you get 1.98?
I did. I found that by using the calculator. Right. right? Because the cosine is inverse cosine for negative is not going to get you a reference angle. It's going to take you directly to the quadrant 2 because of principal values. Yeah.
Where do you get the?
Okay. I have to figure out what that 1.1573 is by subtracting pi minus 1.98427. Before, right? Everything else we're always going to start here. But this time it's strange. We have to, they're giving us this angle and we have to figure out the reference angle so that we can get to the third quadrant value. Okay, any questions there? I know that this is going to be the difficult one because it's just different from everything else. So let's try another one of these because this is what's different. Yes.
How do we know where to round? Or does it matter?
Oh, the direction says round to the thousands place, so just round to 3 decimal places. Okay, if our answers are off by 1, that's not a big deal. Okay, as long as you're just trying to get to that third decimal place. Okay, so let's try another one of these. Can you guys try number 8? Try number 8. Because you should be good with everything else. It's just the inverse cosine negatives that's strange. Okay, 1.740 is not a reference angle. It's too large. So we know because of principal values, inverse cosine for negatives will give you a second quadrant measure. So we have to use that to help us get to the reference angle. Pi minus 1.74 will give us 1.4. Once you know that 1.4, you can use that to help you get to that third quadrant measure that we want. So pi plus 1.4 gives us 4.54. Yes. Yeah. So you'll see 2 sections on the quiz. One will be, hey, give the answer in degrees. Second, give your answers in gradients. So today right now we're practicing the same thing as yesterday, just in terms of radians instead of degrees. Okay, any questions here? Yeah.
So for these problems for cosine, does be quadrant 2 and 3? Not.
If it's negative.
Okay.
If it's positive, then it'll just be 1 and 4.
Okay.
Only negative cosine do you have to do a different set of steps. Everything else will feel the same. But anytime you get a negative theta in return, that will be your reference angle. Just make sure that you put positives, in your diagram. Okay, so if you guys are good with this, maybe we'll come back to this, but I want to go to the quiz review. So if you guys picked up the quiz review, we're going to start on the first page. Okay, let's walk through these. So just as a reminder, if we're dealing with principal values, right, arc sine is going to be quadrant 1 and quadrant 4. But with arc sine, remember quadrant 4 is going to be negatives, right? Like negative pi over 3, negative pi over 4, negative pi over 6. Arc tangent, same thing, quadrant 1 and quadrant 4. It's arc cosine that's a little bit different, right? Arc cosine, principal values is going to be quadrant 1 and quadrant 2. Okay, so let's start off with number 1. Arc tangent -1, that's basically, you see that uppercase A, that means looking for principal value. Is asking tangent, where is tangent of theta equal to -1? Principal values, we know that we're dealing with quadrant 4 because negatives. Okay, so where's tangent going to be -1? Right, it's going to be variation of pi over 4, but we're not going to say 7 pi over 4, we're going to say negative pi over 4 because we're delving into that negative region anytime we're dealing with principal values. Okay. Uppercase C, principal values. Where is cosine of theta going to be -1? Quadrant 2. Theta equals what?
135.
Cosine though, cosine. Pi, right? Order pair at pi is -1, 0, right? Cosine is the x value. Okay. Inverse sine, same thing as saying when is sine of theta equal to -1/2? Quadrant 4, right? So where is sine going to be? Where is sine going to be variations of 1/2? Pi over pi over 6, right? Unit circle values, pi over 6. But it's quadrant 4, so we need to make this negative pi over 6. Right, think about sine of theta. -1/2. But we, instead of calling it 11 pi over 6, we're calling it negative pi over 6. Okay, tangent of theta equal to √3. Think of √3 as √3 over 1. Which quadrant? Positive, so first quadrant. Tangent is y over x. Where's tangent of theta going to be √3 over 1? Pi over 3, right? √3 over 1, y over x. Right? Yeah.
Are we gonna get unit circles on this quiz?
I'll give you a blank unit circle, but you can also double check with your calculator. Okay. Okay, number 5, two-step process now. Okay, if you ever see a a trig within a trig, you're gonna have to always deal with the inside first, okay? Work from the inside out. So let's just solve the problem inside first. This is basically saying when is tangent of theta equal to negative root 3 over 1? Okay. We're dealing with fourth quadrant, right? Principal values. So tangent equal to negative root 3. Say it again. Negative pi over 3, right? Negative. We can't say 5 pi over 3. We got to say negative pi over 3. So now that we have negative pi over 3. Are you coming tomorrow to finish off the lunch or yeah. See you. So now we can shift our focus and solve the larger problem, right? We figured out the inside, which is negative pi over 3. So now we're asking ourselves, what is cosine of negative pi over 3? Yeah, same thing as asking what is cosine of 5 pi over 3, right? 1/2. So anytime you see a trig within a trig, you got to do 2 steps. You got to figure out the smaller, solve the smaller problem, and then work to the larger problem. Like start inside and work outside. Okay, so first things first, let's figure out what is sine of 2 pi over 3. Yeah, root 3 over 2. Once you make that substitution, now you can move on to the larger problem, which is saying when is cosine of theta equal to root 3 over 2? Positive, so now you know that principal value, this is dealing with the first quadrant, so theta is equal to what? 5 or 6. Okay, let's solve the smaller problem first. Tangent of 7 pi over 4 was tangent of 7 pi over 4. One or negative 1? Negative 1. So now that you have that larger problem solved, we can now figure out what is sine inverse of negative 1. In other words, where is sine of theta equal to negative 1? Okay, this is principal value, so negative sine is going to be in which quadrant? Fourth quadrant. Okay, so how would you represent that? Well, it's 3 pi over 2, but principal values is going to be what? We're going to force a negative, right? So negative pi over 2. Yeah. Okay. Work the inside portion first. This is saying where is sine of theta equal to root 3 over 2? You see that uppercase S, positive, so first quadrant. Where is sine equal to root 3 over 2? Pi over 3. Now, we got to bring down this 2 as well, right? So it's going to be 2 times pi over 3. So now we can put it together and solve the larger problem here. What is cotangent of 2 pi over 3? Yeah, so we know it's going to be negative. So negative 1 over root 3, x over y, or you can say negative root 3 over 3. Yeah.
Is it okay on the quiz if we leave it as?
Yeah, either one is fine.
Okay.
Okay, so now we're moving to problems where we're going to create a triangle so that we can have something to work with. Okay, so these are not going to be special angles that we can find on the unit circle, but we're going to rely on Pythagorean theorem and drawing our triangles. So we want to figure out a scenario where cosine of theta is equal to negative 5 over 13. Okay, so where's cosine going to be negative? second, right? We're talking about principal values, so second quadrant. So draw your triangle in the second quadrant. Where does the 5 and 13 go? Adjacent over, yeah. Pythagorean theorem, a squared plus b squared equals c squared. That's the positive y value, right? So positive 12. So now all we want to do is to figure out what is the cotangent of this resulting triangle. What's cotangent of theta? Negative 5 over 12. Okay, number 10, now we're dealing with variables, but same thing applies. We're just going to create our triangle from what's given to us. Now, if you don't see a denominator, you can always put a what in the denominator space. Put a 1. So let's figure out what will this triangle look like. Tangent of theta equals 2x over 1. First quadrant. Okay, where does the 2x go? Where does the 1 go? Opposite and adjacent. Okay, Pythagorean theorem, a squared plus b squared equals c squared. So we filled this in here. All right, what's cosine of this resulting theta here? Adjacent over hypotenuse, yeah. Okay, questions with 10? Okay, let's draw a triangle here. Sine of theta is equal to 5 over x. Draw your triangle in the first quadrant. Opposite over hypotenuse. A squared plus b squared equals c squared. Okay. Once you have your triangle figured out, then you can move on to the outer ratio. Tangent of theta is opposite over adjacent. Yeah. Inverse cosine of x over root 7. A squared plus b squared equals c squared. once you have the triangle filled out, then we can figure out the outer ratio, right? What's cosecant of theta?
Whatever.
Cosecant is hypotenuse over opposite, right? Hypotenuse over opposite. Okay. Can't cancel the square root of 7 out, right? Because there's that minus sign, so this is kind of stuck written out that way. Okay, how do you guys feel? First page. Okay, just if you see a trig within a trig, just work from the inside out, right? Get that inside portion figured out. Once the dust settles, then you can figure out what the outer trig ratio is. Yeah. Uh-huh.
For number 9, how do you want to draw the triangle in the second one?
Because we're dealing with, you see that capital A? That means we're dealing with a principal value for cosine that's negative. Cosine is negative in the second quadrant because the principal value is here.
Okay.
Now, if it was arctangent that's negative or arc sine that's negative, then we'll draw it in the fourth quadrant. But if you're dealing with variables, you're always going to be dealing with just the first quadrant. It's just if you're dealing with values that's just a ratio of numeric values, then you got to decide which quadrant it's going to live in. Okay, good. All right. So any other questions on the first page? Okay, let's go to the back. Just more review from what we did from yesterday and today. So go ahead and try that. And if you get through 13 through 18, I have 2 more for us to practice with. Okay. Okay, does anybody still need to look at first page? Okay, try the back. The top portion is degrees. So make sure you're in degree mode for 13 through 15. And then 16 through 18, switch over to radian mode. And I'll put 19 and 20 on the board if you're able to squeeze that in. Okay, put a star next to 14 and 17. 14 and 17, right? Those are the ones that inverse cosine with negative ratio is the tricky ones. Remember, this is degrees, so you gotta do 180 degrees.
Oh, okay.
And then this will be first and second. Sine is first positive.
Oh.
Check your answer for 13. Any questions?
So for sine, the quadrant one is going to be either.
Always positive. Well, basically, yeah. If your arc trig is positive, then you're always going to involve quadrant 1.
And it's always going theta.
Always theta, yeah. Always looking for that angle. Okay, 14. Got that negative cosine going on here, right? So recognize that. See, degrees is easier to spot, right? You see that theta equals 157, and you know that's not quite a reference angle because you recognize that's not less than 90. So you know that's automatically second quadrant. But we have to go through that additional step of figuring out that reference angle so that we can use it to help us move to the third quadrant for our second answer. Okay, you're going to experience a similar thing with number 17, but just have to recognize that it's going to feel more abstract with radians, but it's the same process as what you did with 14. Any questions 13 through 15? Okay, so the next set, make sure you go to your calculator and change your mode, right? Change it to radians. And now instead of working from 180 and 360, you're going to work from pi and 2 pi. Again, pay attention to number 17. You're going to experience 17 the same way they experienced number 14. It just feels more abstract because you may not recognize that the theta is already in the second quadrant. And if you get done 16 through 18, then hopefully you have room to put 19 and 20 at the bottom of your sheet. Here's 16. Does anybody still need to look at 13 through 15? 16.
How did you get 2.532?
So I got 2.532 because I know I'm looking for a second quadrant. So it's going to be pi minus 0.609. Okay, here's 17. Any questions with 16 or 17? Okay, 19 and 20. Okay, let me just come around and just check your sheet. I still have a help session tomorrow, fourth period. Make sure you bring your calculator. I will send out a reminder this afternoon. Okay. Okay, quiz tomorrow.
Very few years there.
Thank you.
Razors.